In this video, we will walk through the development of a very simple example of a mobile application that will run on both iOS and Android devices using a single code base. This is accomplished with the use of the Open Automation Software PCL, or Portable Class Library, along with Xamarin for Visual Studio. Xamarin is a development environment that lets you build and deploy applications for multiple devices such as iOS, Android, and the Windows Universal Platform. It compiles C# code down to each native runtime, so they are truly native apps with the best performance and familiar controls. What you're looking at right now is an example of what we can accomplish with the suite of open automation software development tools. With the WPF tools, we can create a native scalable HMI for a Windows desktop machine. This is an example of a similar HMI developed with our Web HMI product. And now with the PCL, we can create native HMIs for Android and iOS as you see here. All four of these applications are running against a single server at the same time to display real-time data and provide operators with the ability to monitor and control remote systems on any device or desired client. So let's get started building your first Xamarin Forms app using the Open Automation Software PCL. Our first step is going to be making sure that we have the OAS service control open and we stop all the services. The next step is going to be going to the PCL WCF registration and clicking on Register. We're going to use a default port number of 58725 for this. Then we can make sure that all the services are started back up again. Next, we're going to be taking a look at the tag configuration. So we open up the Configure Tags application, and then we're going to go down to the local host. And the tags we're going to be using today are the pump.value. This is a Boolean, and right now it's currently set to true. And we're going to be monitoring the sine.value, which is a simulated sine wave. So we'll just close this application down, and next we'll be opening up Visual Studio 2015 Community Edition. This has the Xamarin additions added into it. This video is not going to cover how to use Xamarin and all of its features, but just make sure that you have the Xamarin additions added into your version of Visual Studio. So we're going to be opening up a new application, new project, and this is going to be the cross-platform C# project, and you see here it's Xamarin Forms Shared. We'll just rename the project to something like Xamarin App. Hit OK, and you'll see a lot of individual projects being created. One for Droid, one for iOS, there's WinPhone, and UWP, which is the Universal Windows Platform, and even a Windows version. And then there's the main Xamarin app. This is what you should see getting started with Xamarin Forms. And what we'll do is we'll take a look at the structure of this solution. It contains, at the top, there's the Xamarin app, and then there's individual projects that you saw being created. There's Droid, iOS, Universal Windows Platform, Windows, and WinPhone. We're going to be removing all of these projects except for the Android and iOS versions. It makes development a little bit easier when you only have the two target platforms that you want to work with. We'll only be working with those two. There's also this main project which has the shared code, and this is where all of the application code is going to be written. And you'll have a single code base that also has these different events like on start, on sleep, on resume, and all this will get compiled down to the native versions. But at first, we have to add our references. We're going to be adding in the reference to the OAS PCL. This is the PCL library that's the Open Automation Systems component and the data connector. So we're going to add in the OAS PCL, Sharp Serializer. Sharp Serializer is an open source portable class library that does binary serialization that we depend on. There's a validation DLL. This is another portable class library. And the last bit is the PCL crypto for cryptography. So we're going to repeat the same step for the iOS project because we just did this for the Android project. You'll need to do this for every project in the Xamarin Forms shared application. You don't have to add this into the Xamarin app, the main Xamarin app, because this actually can't be done. This is only available to the individual target platform applications. And that's so that you have unique references for each one that may or may not be specific to each target platform. Now let's write some code. I'll just fix some deprecated code that the template wrote for us here. Now we're going to add in a using statement that adds in the OAS PCL assembly, and this will let us use the components under the namespace. The components that we're going to add in, we'll create a couple of references here. They're going to be the OPC Systems component and the OPC Systems Data component. We'll create two instances. The OPC Systems component does the work of administering elements on the server, which we won't really be doing in this demo. And the OPC Systems Data component is what you'll use when you want to monitor data, and if you want to get real-time data feeds, or if you want to set values on the server. I'm also adding in an IP address here. This is my local server. It's not the local host reference, it's the local address on my network for my machine. This will be different for you. Just make sure you use the real IP address of your machine, not the local host address of 127.0.0.1. So I'm adding in a label, LBL sign, which is going to be the label we'll use to display the value for the sign.value tag. And I'll give it a default text of loading. So when the first time the app opens up, it'll just say loading, and then when data starts flowing in, you'll see the real values. The horizontal alignment is going to be centered. And I'll do the same thing for a label that was going to hold the pump.value. So I'll call this LBL pump. Same deal here, I'll give it the text, default text of loading. And horizontal text alignment of centered. So in order to actually change the values on the server, we'll need a button, something that'll monitor a tap or a click event. So I'm going to create a button called btn pump. This is a Xamarin Forms button. And I'll just set the text on that to toggle pump. The last bit here, I'm just going to clear out the current children of the content on the default Xamarin Forms layout. And I'm going to add in the three elements that I've just created, the two labels and the button. So in order to monitor the click events of this button, I'll have to add a handler. So I'm going to be monitoring the clicked, and this will automatically create a handler function. And I'll just put a comment in here so that we know to implement this in a bit. And we'll go down to the onStart. So we'll want to do some initialization on the onStart. This onStart gets triggered when the application is loaded up, it's gotten past any splash screens, and the application actually starts up. So in here we're going to set up the tags that we're going to monitor, and we're going to set up an event handler for when the tags change. The OPC data component, it will fire off an event so that when values change on the server, we'll get an event to handle, and then we can iterate through the tags that we're going to be updating. So in order to monitor a tag, we're going to use the OPC data component here. We'll fire off the add tag, and I'm just going to do some string formatting that will include the server IP address. We'll do the same thing for the pump.value. Now I'm doing individual calls here for add tag, but there is a function within the data component that lets you add multiple tags at once. But for now, I'll just use these single executions just to make the code simpler. And the last piece of this, when these tags are being monitored and when their values change, we want to fire off an event. And that's the values changed all. Every time the values changed all fires off, It will include an array of tags that have changed, their values, their current values, the data qualities, and the timestamps of when the change occurred. I'll just add in a note here that says we're going to be iterating through the received values, and then we're going to update the display accordingly. So in order to make this happen, we actually have to create a Lambda. I'm not going to cover how to use Lambdas in C# or within .NET, but this essentially just says this is going to be an anonymous function that's going to fire, and this is a special one. This is device.begin invoke on main thread. This tells us to execute this code on the UI thread. This is not going to be executed on the thread which is handling the event. This is very crucial because we want to make sure that we marshal over this execution to the UI thread, because we're going to be changing UI elements. If you don't do this properly, or if you don't do this when you're handling an event and changing UI elements, it could cause a crash or unexpected results. So within this Lambda is where we're going to be iterating through the tags. I'll just copy and paste in some code that I've already written, which does all of the work. You'll immediately see that there are some errors. These are just some missing variables I'll need to create, and I'll explain what we'll do with those. First one is a Boolean flag. I'll just call this pump set, and I'm going to use this as an indicator as to whether we've ever gotten a value from the server for the pump.value, and then we're going to use the pumped val, which will hold what the current value is. Now we see that those errors are gone, and I'll explain what this code does. So the first thing is we're going to be iterating through these tags, and I'm going to be checking to see what these tags are in the array. And if it's the sign.value tag, I'm going to set the label for the sign.value. And if it's the pump.value tag, I'll initially say that we've gotten a value for the pump, and we're going to set the value on the label as well. Now we're going to start handling the event for the button. So I want to make sure that we don't set the value on the pump.value until we've gotten a value from the server to begin with. So in another Lambda here, I'm going to be executing a call to sync write tags. This is actually going to take the value of the pump.value, negate it, and send it up to the server. So whatever the current value is, it's just going to reverse it. So I'll just do some compiling here, see if everything works. First thing to note here is that we're getting an error. Now this just says that there's no installed provisioning profile, because by default it selects the physical iPhone that it wants to deploy to. So that error can be slightly confusing, because you'll even get that compilation error even if you're trying to compile the Android application or the Android version. The reason is because we have an iOS version in the project solution, so it still tries to see if it can hit the deployment target of an iPhone when it's building the runtime. So in order to connect to a simulator, you have to have a Mac on your network or a local machine if you've got a virtual machine going. And once you've connected, you should be able to pick the simulator. And then once you pick the simulator, you can choose which version of the simulator that you want to deploy to. In this case, I'm going to be doing the iPhone 6s using iOS 9.3. Make sure that you've got the Xamarin app iOS version selected if you want to deploy to that, rebuild, and you should be able to compile without any issues now. So now we see that everything has succeeded, and we can go ahead and give this a shot by actually running it in debug mode, and it should deploy out to the simulator and start right up. Switch over to the Mac screen, and here we've got the simulator, and you'll see the Xamarin logo pop up. You can change that logo when you want to, and it's just part of the project. And now we see the data streaming through. This is the value for the sign, and now we can even see that when we click on toggle pump, it sends up to the server the message to change the pump value, and it changes the label based on the value being set on the server. So everything seems to be working in the iOS version. We'll stop this. We'll go over to the Android version. And instead of connecting to the simulator, we have a comparable application, which is the Xamarin Android player. And we want to make sure that we've got the IP address on that player, currently running the Marshmallow version of Android. There's a console that you can open up, and the way you connect into it is you type ADB connect, and you get the IP address of that simulator that's running on the machine. It should connect right away. And you'll also see that it becomes an option to select for a deployment target. Run that in debug, and we should see it go. It starts right up, and you see similar labels. You'll see the sign values coming through. You see the label for the pump value, and when you toggle the button, it works just the same. You will notice some visual differences. Now that's because Xamarin Forms creates the native, comfortable controls for each target deployment platform. So in this case, it's using the iOS buttons, and it's using the iOS labels, and over here it's using the Android buttons and labels. So this allows you to create a UI that is comfortable on whatever platform it is, and it fits in with all the other applications. And you don't have to create a style that's independent of those. So what you'll see here is that it creates the app within the Android folder, and same thing on the iOS. It creates an app that you can start up at any time. For more information about our products, go to openautomationsoftware.com. You can find all of our documentation in the openautomationsoftware.com/online help section. You can check out the programmatic interface, which we used in this demo. Well, in this demo, we use the Portable Class Library, or PCL. It follows the same interface that we use for our desktop versions of the OPC Systems component and OPC Data component. For more information about Xamarin, you can go to xamarin.com, where you can download a standalone IDE, or you can learn more about how to integrate it with Visual Studio.